Hi everyone, in this video we will discuss the problem of the day. Print n bit binary numbers having more ones than zeros. So let us read the problem statement and then we'll try to see what the problem says here. So the problem says that we have been given an integer that is n, and our task is to generate string of all n bit binary numbers where for any prefix of the number there are more or equal number of ones then zeros. So the number should be sorted in decreasing order of magnitude. So you can see here that if the n value is 2, then the strings that we are going to make, or the binary numbers that we are going to make, they should have the count of ones greater than or equal to the count of zeros. Okay, and the final answers, the list of elements should be in the decreasing order. So you can see that when n is 2, so we can have 2 bits. So either we can have both the bits as 1 and 1, or okay, because in this case the count of ones is greater than the count of zeros, or we can do what, like when we have 1 0, so in this case you can see that the count of 1 is greater than equal to the count of zeros. Other than this, if we would have chosen anything else, then it would have not worked. Okay, so you can see that for any prefix of the number, the number of 1 should be greater than equal to 0. So that is why 0 1 will not be considered. Why 0 1 is not considered? Because if you see the 0 1, then for the prefix 0, you can observe that the number of zeros are greater than number of ones. This violates the condition. That is why the 0 1 binary number is not considered, as well as 0 0 is not considered, because obviously 0 0 will not satisfy the criteria. Okay, so let's now try and see how we can do this. Obviously, when we have to solve such kind of a problem and we have to generate all the possible scenarios here, all possible valid scenarios, then which concept comes to our mind? The concept of recursion should come to our mind, because if you have to generate all possible scenarios here, then recursion will come into play. So let us see the test case when we have been given n as 2. So when we have been given the n value as 2, so this means that we have to generate two numbers, right? So what we can do is, whenever we have been given a n value, so whatever n value we have, initially we can say that the count of ones would be how much? It would be 0, and the count of 0 would be how much? It would be 0. Okay, now initially we will start with this, and initially you can say that our string will be what? Initially our string will be nothing but empty as of now, because we don't have anything. Right, now after this, we have two options. One of the options is that whatever string we are having, in that string we can directly add 1. Okay, so what we can do is, one of the choices is that we can say that one digit we can apply as 1. So we can say that the string will become what? Here the string will become 1 only. Okay, and then the count of 1 will increase by 1, it will become 1, and the count of 0 will remain the same. Because if you add 1, so there is no problem, because since we are adding 1, so this only increases the number of ones, and this will make sure that the number of ones are greater than equal to the number of zeros. Because if we are adding 1, so that does not create any trouble. Now when will we try to add zeros? That is what we need to understand. Okay, so we will add zeros only when the number of ones are greater than the number of zeros. Okay, so if you will see at this point, so you can see here that in this starting phase, the count of 1 is 0, and the count of 0 is also 0. So from here, the string is basically empty. Would you like to add 0 here? No, because if you add 0, then in the starting prefix, the number of zeros will become more than the number of ones, which is not acceptable. So that is why this choice should not be allowed. So when will you allow to add zeros in your bit representation? You will allow to add zeros only when the number of ones are greater than the number of zeros. Okay, so basically from here we will not be making any calls, right? So from here you can say that you will not make the call of adding 0. Now from this place, what will happen is, from here you can do what, like n can be 0, like now n will become 0 if you take one more digit, and then the string would become what? If you take 1, then it will become 1 1. Why we are trying to add 1 first? Because we want to generate the answer in decreasing order. So if you add 1 first, then the larger answers would be stored first. Now the string becomes 1 1, and the count of 1 becomes what? 2, and the count of 0 becomes what? 0. Now you can see that n becomes 0. This means that we have generated all the digits, all the positions we have tried to fill a bit, and now the number has been completed in the binary format. So now we will store this number. So in our final answer we will store 1 1 here. Okay, now from here the thing is that will you call for the right also for the state n is equal to 1, okay, and counter 1 is 1, count 0 is 0. From here will we like to call for adding 0 as well? Yes. Why? Because the number of ones is greater than the number of zeros, so this means we can afford to add 0 also. So here the since we are going to take another digit, so n value will decrease and it will become 0, and then the string will be what? It will be 1 0. Okay, and the count of 1 will be 1 and count of 0 will be 1 as well, because we have taken 1 0. And now you can see that this is the string that we get, that is 1 0, and we will add this in our answer also. Why? Because you can see that in this particular string we added 0 only if the number of 1 was greater than the number of 0. So that is why when we'll get the updated string, so it will have number of ones greater or equal to the number of zeros only in the updated string. So that is how you can see that we have got this as well, and from here there will be no other calls. So you can see that all the recursive calls are over for this particular test case, and finally we are getting what we are whenever n becomes 0, so we are getting the string 1 1 and we are getting the string 1 0. So basically we are getting both the binary numbers in this format. Okay, so I hope that you're clear with the idea. The basic idea is that whenever we are at a particular state, right, whenever we are at a particular recursive call, so adding 1 is directly allowed, right? We can directly add 1, and why we are adding first? Because we want to generate the answer in the decreasing order. And then when you will call for 0, so can you always call for 0? No, you will call for 0 only and only when the number of ones inside the string so far are greater than the number of zeros. Only then we will do what? Only then we will add zeros there. Okay, so I hope that this particular approach is clear so far. And since we'll be generating all possible scenarios, so the complexity would be kind of exponential in nature. That is nothing but 2 to the power n. Okay, because at every state we have two choices, either add 1 or add 0. So if you have two choices at every state and you have n states, right, so it will be 2 to the power n, because for one state you have two choices, then for another state of n you have two choices, so on and so forth. You will have 2 to the power n choices. Okay, now let's try and implement the code for this particular problem to see how the implementation will be done. Okay, so basically what we will do here is, first of all, we need to return a vector of string. So this means that we need to return what? We need to return a list of strings here. So that is why we will mark a list of string, let's say as answer, which will be finally storing all my generated strings, right? Binary strings of length n. Then after that, what I can do here is I can say that I'll declare a string which will be nothing but let's say I can mark it as operation, or if I want, so let's say I can mark that string as empty initially, right? And then after this, what I will basically do is I'll say that the number of ones in the string would be 0, and the count of zeros in the string would also be equal to 0. And then after that, what I will do here is I will now call my recursive function. And when I'm calling my recursive function, so initially I'll pass the n value, okay, then I'll pass the string, then I'll pass the count of 1, and then I'll pass the count of zeros as well. Okay, and once this is done, so once my list is prepared, so I will also pass my answer list, because that will get updated once I have built this. So what I will do here is I will simply return my answer that will consist of the list of strings. Okay, now when we are at this point, so what we will do is we will call our recursive function. So we can call void recursive function, and we are having int n. Okay, then we are having what? Then we are having string ampersand, like we are going to have string st, the current string that we have. Let's name it as current, in fact. Okay, so here also let's name the string as the current string. Okay, and then after this we will also be having the number of ones, so int c1, then we'll also be having int c2, and then after that we will also be having vector of string ampersand answer, which will be storing all the answers finally. Now what we will do here is, if the n value becomes equal to 0, then what we will do here is we will simply do answer dot push back this particular current number that we have generated, this particular current binary number that we have generated. Why? Because if all the digit, like if we have generated all the digits finally, so this means that the number according to the conditions have been generated where this particular bit number is always containing the number of ones greater or equal to the number of zeros for any prefix of this number. Okay, now once this is done, so after this what we can do here is we can simply say that we will call the recursive function and we'll mark n minus 1 here, and in the current string we can directly add 1. Okay, and then we'll say that the counter 1 will increase by 1 and the counter 0 will remain the same for this call, and then we can pass the answer here. Okay, the other call will be made if and only if the number of ones, the count of ones is greater than the count of zeros, then only we can make this call. So what we can do is we can call for the recursion of n minus 1. Okay, and then the current will be updated with 0. So we will do what? We will do current plus 0, and then after this what we'll do is we'll do c1, then we'll do c2, and then sorry, c0. So I've written c2, sorry, let's in the definition of the function, let's update it, and now this will be c0 plus 1, because c zeros, the count of zeros will increase by 1. Okay, and then after that I also need to pass the answer here. Okay, so this is how we need to implement it. I hope that I have not made any mistakes here. Now let's try and compile it to check if there are any compilation errors in our code. Okay, so there is one error, that is st was not declared. Yes, because I have named the string as current. So now let's try and run it to check if it is working or not. It does work fine on the samples. For n is equal to 2, it is giving me 1 1 and 1 0. Now let's try and submit this code to check if it is getting accepted or not. I hope it should get accepted. Okay, so you can see that it was able to pass all the 1115 test cases that were there, and this particular problem can be asked in a lot of companies. So I hope that you have understood this problem clearly. In case if you have any doubts, please mention them in the comments, and if you have understood this problem clearly, please give me a +1 or write understood in the chat. Thank you for watching this video. Keep coding.